Students, when light travels through the same medium with the same optical density, it travels in a straight path. As the medium is changed during the course of travel, the velocity also changes, and at the point of separation of two media, the light rays bend. This bending of light as it passes from one medium into another medium is called refraction of light. Students, the materials required for doing this activity are a white sheet of paper, glass slab, pencil, pins, cardboard paper, and a ruler. Now let us look at the procedures. Fix a white sheet of paper on the cardboard paper. Place a glass slab almost at its center and draw its outlines. Draw a straight line on one side of glass slab and fix two pins on its path. This behaves as incident ray. Now observe from the other side of the glass slab and put two more pins that will act as emerging ray. Now all four pins look as if they are in a straight line. Join the dots on this side and draw a normal. Students, in the above figure, PO is incident ray, O' is refracted ray, and O'Q is emergent ray. MN and M'(N' are normal drawn on the surface AB and CD of glass slab ABCD at the point O and O' respectively. PP' is the initial path of the light. The angle between incident ray and normal is called angle of incidence, that is, angle POM. The angle between the refracted ray and the normal is called refracted angle, that is, angle O'(ON). The angle between the emergent ray and the normal is called emergent angle, that is, angle Q, O'(N'). The perpendicular distance between the emergent ray and incident ray produced is called lateral displacement. Students, if we verify the refraction of light through a glass slab, we come to conclude the following laws of refraction. That is, the incident ray, the refracted ray, and the normal all lie at the point of incidence on the same plane. The ratio of sine of angle of incidence to the sine of angle of refraction is constant for any two given media. That is, sine I by sine R is equal to mu, that is a constant. When light travels from rarer to denser medium, it bends towards the normal. When light travels from denser to rarer medium, it goes away from the normal. A light ray which strikes glass slab at 90 degrees goes undeviated. Students, when we look at the pond of water, the rays of light coming from the bottom of the pond are bent on emerging from the surface of the water, and so the pond appears to be shallow. If a rod is partially immersed in a trough, it behaves the same as the stick put in the water of the pond. In this case, the rod or the stick which is partially immersed in water looks bent at the point of separation of the two media, that is, water and air. Rays of light coming from the various portion of rod in water refract away from the normal as they emerge from water into the air. Students, each point on the dipped part of the rod therefore has a corresponding image point. The rod therefore appears bent at the surface to our eyes. Students, when a ray of light passes from a denser to a rarer medium, it bends away from the normal. In the given figure, for ray number 1, the angle of incidence is less than the angle of refraction. As the angle of incidence gradually increases, the corresponding angle of refraction also increases. For a certain angle of incidence in the denser medium, the corresponding angle of refraction in the rarer medium can be 90 degrees. Students, for ray number 2, the angle of refraction is 90 degrees. this particular angle of incidence in the denser medium, for which the corresponding angle of refraction in the rarer medium is 90 degrees, is called critical angle. As the angle of incidence is increased, it will be more than critical angle. In this case, incident ray goes back to the same denser medium. This is called the total internal reflection. Students, ray number 3 has incident angle greater than the critical angle. Therefore, it is totally internally reflected. Here are the conditions for total internal reflection. Students, for total internal reflection to occur, the light ray must pass from denser to rarer medium. The angle of incidence in the denser medium must be greater than the critical angle for that particular medium.